So in this video, we're going to use limit notation to describe the end behavior of functions. So here's the basic idea. I have two pictures here, but the pictures are of the same function. And if we look carefully at this function, understanding that because we don't have a closed dot on either end of the function or an open dot on either end of the function, we're assuming that there's an arrow indicating that this function is going infinitely far to the left and infinitely far to the right. In fact, we could describe the domain of this function, which we've already done, as being x is going to go from negative infinity to infinity. This is the open interval from negative infinity to infinity because x can go to infinity, but it can't get there. Infinity isn't a number, it's a concept. You can never get to infinity, but x can become infinitely large, either infinitely large positive or over here infinitely large negative. And when we talk about end behavior of a function, what we're really asking is, where do the function outputs go when x gets infinitely big, or when the inputs get infinitely big and positive, and where do the function outputs go when x gets infinitely big but negative, infinitely large negative numbers? So for this particular function, I see that as x goes to the left and becomes infinitely large but negative as it moves out towards negative infinity, we see that this arrow has a vertical component that's facing down towards negative infinity on the output axis. So the way that we would describe the end behavior is we use the notation called limit notation. I say the limit as x approaches or goes to negative infinity, and notice that this x goes to negative infinity is under the limit. LIM stands for limit. This goes underneath it. And then we put the function name. So my function's name is f of x. So the limit as x goes to negative infinity, or as x gets infinitely large but negative, the limit is negative infinity because the outputs are becoming infinitely large but negative. Over here, I can describe the end behavior of this function as x goes towards positive infinity. So I can say the limit as x goes to positive infinity of my function f of x is equal to, and then I need to look at the function and I need to say, where are the outputs going? As the inputs get infinitely large along the horizontal axis, where are the outputs going along the vertical axis? And here I can see that the outputs are going up towards positive infinity along the y-axis. So I say, hey, the limit as x goes to positive infinity of my function is infinity. That's where the function is going. That's its end behavior. So here's another example. So here I have a function. When I look at it, I'm going to see I've got an arrow here and here. So I know this function is going infinitely far to the left, or it's going out towards negative infinity along the x-axis. And here I see that the function is going infinitely far towards infinity along the input or x-axis. So if I give my function a name, let's call him g of x, I can say, hey, as the inputs go towards negative infinity, where do the outputs go? And here I can see that my arrow is going up. So my vertical component is up towards infinity with respect to the output axis. So I can say, hey, the limit as x goes towards negative infinity of my function, which I just named g of x, is equal to, well, my function outputs are going up. They're becoming infinitely large with respect to the output or y-axis. And as x goes to positive infinity, the limit as x goes to positive infinity of my function g of x is equal to, well, here as we go towards positive infinity, this arrow here also has a vertical upwards component saying, hey, it's going to positive infinity as well. So here what we see in this example is that the end behavior as x goes to infinity or negative infinity can be the same. It's going to be graph specific or function specific. So here's a final example. I think this is the last example here. So this is one where the end behavior has the function outputs not going to infinity. So when I look at this function, I have a horizontal line here, and the horizontal line is the line y equals 4, and it looks like the function is approaching or getting close to the line y equals 4, either as x goes out towards infinity this way, or as x goes towards negative infinity out this way. This in fact is what we would call a horizontal asymptote, which we'll explore in depth when we get to rational functions. So what I want to notice is that the limit as x goes towards negative infinity, as the inputs go along the input axis towards negative infinity, it looks like this function is approaching the line y equal 4. So we'll give the function a name. We'll say, hey, this is the function h of x. So the limit as x goes towards negative infinity of my function h of x is equal to 4, because it looks like the outputs are getting closer and closer and closer to the horizontal line y equals 4. And we see that the limit of this particular function as x goes to positive infinity, as the function moves out along the input axis towards infinity, it looks like the function's also approaching the line y equals 4 as we move this direction. So we'll say it looks like, based on the graphical evidence, that the limit as x goes to infinity of h of x is also equal to 4. It looks like this function is approaching this horizontal output asymptote.